Almost anything in real life can be represented in code, but how well something is represented is up to us in what we decide to program. Classes in Java gives us a way to model or represent physical objects in code via a blueprint. A blueprint or a class contains a set of attributes and behaviors that defines an object. Let's design a tree object in code using a class. The attributes might be height, trunk, diameter, tree type, other attributes we can add. Every tree has these property or attributes, but their values might not be the same. That's what makes this class a blueprint. It contains the definition of what a class should be. As for the behaviors, growing could be a behavior for the tree. It's an action that the tree takes rather than an attribute representing the current state of the tree. Let's create a blueprint for a tree using class in Java. So I'm on Windows and I'm going to create a new class. So I will name this class as tree. So as you can see, a new class is created. A class doesn't have to have attributes or behavior. It could be completely empty as we see here. It could also just have attributes or just have behaviors. However, most of the time a given class will have both. Let's add some code to the tree class so that it actually represents a tree. Starting with the attributes, we will have a height and trunk diameter. These will have the data type double, meaning they can be represented by decimal values. While we could represent a type of tree with a string, we will represent it with its own enum here called tree type. To create an enum, we will control click on the source folder and we will create a new Java class, let's say, and from here we can select an enum. So I am naming the enum as tree type as I have given in my tree class, and I have selected enum here and I will click enter. So a new enum will be created, and if you can see, the error disappeared from there. We will call this enum tree type. Enum is a special type that represents a group of constants. Here we will want those constants to be different tree types. These are the only values we can give to a variable with the tree data type. By using an enum, no one can create a macaroni tree or money tree, people tree, which would be the case if we used a string. The only tree types that can exist are those listed in the enum class. To use this enum, all we have to do is use the data tree type for a given attribute or variable, which is what we have done here. Now our class has attributes. So these are the tree types I have given in my enum. Now let's add the grow behavior to finish up our definition of a tree. A behavior is represented by a function. Our function will return void and be called grow. Inside this function, I will define the height of the tree plus 10. In the implementation, we will access the height and trunk diameter of the tree and increment them accordingly. To keep things simple, we will say all trees will grow 10 feet in height and 1 inch in diameter when this behavior is used. However, you could use the type attribute or other data to inform how much the tree grows. There are many different ways a tree can be represented in code. Great. Now we have combined the attributes and behavior related to a tree into a single unit. The tree class, remembers, it's a blueprint because we are only defining the attributes and behavior of a tree. We haven't created any trees yet. Our class says if we wanted to create a tree, this is how it would be represented in our program.